Assalamu alaikum students. This is Chemistry 12 Annual Examination. You mean Secondary Chemistry, Board of Intermediate Education, Karachi. So today this paper was conducted, and this is the question number 1, that is MCQ section A. So choose the correct answer for each of the following given option. The first MCQ's first multiple choice question is that this give violet color to the flame. So the lithium gives the red color, sodium gives golden yellow color, and potassium gave lilac or violet color. So the correct option is this. Potassium is the correct answer. So this is the correct answer. And if you see the beryllium, so you should remember that beryllium has no color. It gives no flame color. And also remember that magnesium gives silver white fumes and silver white flame. Calcium gives orange red color. Strontium gave deep red or crimson red color. For strontium, we usually say crimson red. Crimson red color. And barium gives pale green, very light green color. Okay. Anyway, so our question was about the violet color. So violet color is given by potassium. Next is the order of reducing power of halide ion. Remember that halide ions can be used as reducing agent. So the reducing capability increases down the group. So the best reducing agent is at the bottom. So fluoride, chloride, bromide, iodide. So this is the sequence. So the best reducing agent is this. So first one is the correct answer. Iodide, bromide, chloride, and then fluoride. But if we talk about oxidizing capability, then oxidizing capability is more for fluorine as compared to chlorine, as compared to bromine, and as compared to iodine. But here we are asking about reducing power of the halide. So reducing power is the reversal of this oxidizing power. So the correct option is the first one. Okay, now see the next question. The next question is about coordination number from transition metals. The compound is Cr, En thrice, overall charge is +3. So they are asking about the coordination number. So if you know what is En, En is ethylene diamine, and the structure of ethylene diamine is this. It is ethane 1,2-diamine. So both of these nitrogen in amine group work as a electron donor. So this is a bidentate ligand. If 3 of these ligand are there, it means they can provide 6 ligand. So the octahedral complex is formed and the coordination number is 6. So the correct answer is 6. And next question is, this fertilizer provide nitrogen and phosphorus to the plants. Urea, the structure of urea is on both the end there is NH2. So it can provide nitrogen, but not the phosphorus. Potassium nitrate is KNO3. So you can see here only nitrogen can be provided. Ammonium nitrate. Ammonium is NH4 and nitrate is NO3. So ammonium nitrate do not have phosphorus. So all of these three can provide nitrogen but not phosphorus. But the diammonium phosphate is this molecule, 2 ammonium and phosphate. So this diammonium phosphate, it has phosphorus as well as nitrogen. So this is the correct option. Diammonium phosphate is the correct option. Now, this is the hottest part of the atmosphere. So we should remember that the hottest part is the thermosphere, where the temperature rises up to 1200 degrees Celsius. And next is cathode in Castner-Kellner process. If you see the diagram, then you can see that titanium blocks are there. But actually, mercury act as cathode. It reduces sodium ions and convert them into sodium metal, and sodium amalgam is formed. So mercury itself works as a solvent as well as cathode. The floating or the flowing cathode is there. This is the advantage of that process. Next is the diagonal relationship. If we see that the diagonal relationship, so in periodic table, if we see these two groups of the periodic table, group 1 and group 2. So here it is the lithium, then sodium. Here there is beryllium, and here it is magnesium. So in diagonal relationship, this is the diagonal of this square, and this is called the diagonal relationship. This lithium is diagonal to magnesium, or in other words, vice versa. You can say that magnesium is diagonal to lithium. So the correct answer is magnesium. So magnesium is diagonal to lithium. And the next question is that this is low quality coal. So the peat is the low quality coal. You can read it from the table in periodic in your book, that peat is the very low quality coal, and anthracite is the very high quality coal. So now we will see the next question. Now see the question, MCQs number 9. This is used as ink preservative. This is from the uses of phenol in your book, that is given on page number 179. And the answer is phenol. So the correct answer is phenol. And this one is more acidic. This question is also from phenol and carboxylic acid. And definitely we know that water, the acidity of water is very low. Or if we compare carboxylic acid and phenol, so phenol is very weakly acidic. The pK value of phenol is approximately 10. You can see it on page number 173 of your book, that the pK value of phenol is 10, while the pK value of carboxylic acid is 5. And remember that if pK value is lower, it means it is more acidic. So it is much more acidic than phenol, and alcohol and water are almost neutral. So they are considered as neutral compound. So if we compare the acidity of phenol, so carboxylic acids are more acidic as compared to phenol. So the pK value is given on page number 179. Sorry, not 179, on page number 173. Page 173 of your book. Now, this is a meta-directing group. So remember that almost all the meta-directing group have either the carbon double bonded oxygen, nitrogen double bonded oxygen, or multiple bonds of that elements are there, which is directly attached to the benzene ring. So if you see, then OH cannot be, because it has all the single bonds, and it is lone pair that can contribute with the benzene and make it more electrophilic and more electrophilic at 2, 4 and 6 position. And it also has lone pairs, so it also make more nucleophilic. Benzene is made more nucleophilic by this because of the lone pair. So the 2, 4, 6 position becomes more negative or more nucleophilic. If we see here OR also has lone pair. This is alkoxy group. So alkoxy groups are also orthopara directing, 2, 4, 6 directing groups. But cyanide, this nitrile group has CN. So the electron more easily transferred to the nitrogen. So instead of giving electron to the benzene ring, it captures the electrons from the benzene ring. So it has the withdrawal effect. So all the groups which are having multiple bonds are usually meta-directing groups, except the CF1. CF3 is the group, it is also meta-directing, although there is no multiple bond. If you draw the CF3, it would be like this. And this is the only halogen containing group that is meta-directing. It is also meta-directing. But remember that CCl3, it is orthopara directing, 2, 4, 6 directing. If you talk about OCBr3, it is also orthopara directing, but this one is the meta directing because of the very high electronegativity of fluorine. Anyway, so from here in our description, only the cyanide, that is the nitrile group in terms of organic chemistry. This nitrile is the correct answer. This is the meta directing group. Lucas reagent is a mixture of, you should remember this. This is a mixture of zinc chloride and HCl. So student may confuse with the zinc and HCl. Remember that this is not the Lucas reagent. Lucas reagent is only this. The hybridization in carbonyl carbon of aldehyde and ketones. So you should remember that in carbonyl group, wait a minute. Okay, so what is the carbonyl group? You can see that this is the carbonyl group. In ketone, both the ends have alkyl groups, but in aldehyde, one of them has hydrogen. Anyway, if you see that here carbon is forming one double bond and 2 single bonds. And in these cases, the hybridization of this carbon atom is sp2. Wherever there are 3 domains of electrons, because this double bond, both the electrons are in the same directions. So 1, 2, 3. In this case, the hybridization is sp2. So the correct option is sp2 hybridization. Next, MCQs number 14. This molecule contains ketonic group. So remember that glucose and galactose and mannose, they are aldoses. So if they are aldoses, so they are polyhydroxyaldehydes. Fructose is a ketose, one of the ketoses. So it must have a ketone group, polyhydroxyketone. If you want to see the structure of fructose, it is this. This is the ketone group. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. Okay. And here OH is there, OH is there, H is there, OH is there. So this is the structure of fructose. It has one ketone group. This is the ketone group. And it has two primary alcohol groups. One is this, another is this. And three secondary alcohol groups. This is secondary alcohol. This is secondary alcohol, and this is also secondary alcohol. So the correct option is fructose. So this is the correct answer. Now the next question, MCQs number 15. Ozone layer is present in, it is present in stratosphere. So this is the correct answer. You can see it in your book, and the page number of the book where you can find stratosphere and ozone layer. It is page number 260. So on page number 260, you can see that ozone layer, and they have written a sentence as well. This region is distinguished by the remarkable presence of ozone layer. On page number 260. So you can confirm it on page number 260. And the next is the carbolic acid. This is not carboxylic acid. Carbolic acid is another name of phenol. So now you can understand the phenol has this functional group on aromatic ring. Okay. In S block element that form the superoxide. So cesium is the answer because superoxide are formed by only three elements that are mentioned. These are the potassium, rubidium, and cesium. Francium is also expected, but as it is a rare element, not rare, its abundance is low, and we have very low information about low info, very less information about francium. So only these three form superoxide. So the correct option is cesium. So that was the question number 1. Now we will see other questions, especially from section B. Then we will proceed to other questions.